got that done. All right, so thank you very much for the invitation. I really appreciate the opportunity to talk to another Texas A&M school. And I'm going to talk about, sort of give you guys an update about climate science. And I'm going to make the argument that we're really in this unique situation where we're sort of the first people who are about to get hammered by climate change, or really the last people who can do something about it. And so I'm going to start off with really the only science plot of the talk. And this is what it looks like. So this is 30,000 years of the Earth's global average temperature. So it goes from the depths of the last ice age, about 20,000 years ago. We're right here, and this is the next 10,000 years. And so ice age, we come out of the ice age, we enter the Holocene, and then this is the very pleasant interglacial that humans essentially developed in. Now you'll notice this is a really weird thing. What the heck is going on there? Well, it turns out that's the fossil fuel era. You know, looked at it on geologic timescales, the fossil fuel era is going to be this brief spark in the history of humans. It's last a couple hundred years. That's it. You know, we started burning fossil fuels in maybe 1800, and you know, maybe we'll stop in the next few decades. Maybe we'll stop in the next century or two. But we're going to stop, and we're going to stop on relatively soon. And yet, despite the fact that it's this brief period, it has this enormous impact on everything. You know, we live lives of unimaginable luxury because of fossil fuels, but it's also, as you can see, it's changing the climate in an enormous way. It's sort of business as usual suggests it's about 6 degrees warming. And I've converted everything to Fahrenheit. I assume that's what lawyers prefer. So about 6 degrees Fahrenheit. Now, you are completely reasonable if you say 6 degrees does not sound like very much. I mean, it was, a few days ago it was 90 degrees in Texas. So why should I care about 6 degrees? Well, the important thing to understand is we're talking about the global average here. We're not talking about local temperatures. And if you look at the global average, the last ice age was 10 degrees cooler than we are now. So you think about, really think about that for a minute. If you cool the world by 10 degrees Fahrenheit, global average, you get an ice age. Now let's imagine we warm the climate by 6 degrees. That's 60% of an ice age of warming in 100 years or a few hundred years. That's a lot of warming. That's going to reshape the planet. You will not recognize the planet with 6 degrees of warming. It will look completely different than it does now. So people always say, oh, you can't predict the future climate. Let me show you some of Exxon's predictions from the 1980s. So Exxon did a lot of predictions right around here. They started making predictions. The red line is the observed temperature change, and these gray lines are what Exxon predicted. And you can see Exxon got the predictions right. And this is kind of a joke, saying Exxon did it. So we've been accurately predicting the global average surface temperature for decades. So we can definitely predict this. When we say we're on track for 6 degrees, you can take that to the bank. There's not a lot of uncertainty in that prediction. There are uncertainty in other predictions, but not that one. All right, so let's get back to here. So we are here. We've increased the climate by about 2 degrees since pre-industrial. So we're about a third of the way on the 6 degrees. And we're about 1/5 of an ice age. That is a lot of warming. We've already warmed the climate, to say it again, we've already warmed the climate 1/5 of an ice age of warming. And we're beginning to see things happen in response to that. Well, I can keep talking. I can always keep talking. And I'll just say, because I don't want you guys to sit there. I was getting on a roll. So I would show you a bunch of headlines. My next slide is a bunch of headlines. So Hurricane Harvey, the U.S. Southwest is drying out. Lake Mead, Great Salt Lake, I don't know if you've heard that. That's disappearing. Now, climate change doesn't cause any of these things, okay? But climate change is a threat multiplier. Climate change is like steroids. For a baseball player. Steroids don't hit home runs, but steroids make the ball go further and turn a routine fly ball out into a home run. And climate change does the same thing. It doesn't cause a hurricane, but what it does is it makes the hurricane more destructive. It raises sea level, that increases storm surge, it increases the amount of rainfall, it increases the intensity, so it makes these things more destructive. And with 2 degrees of warming, you would expect, because that's a lot of warming global average, you would expect to see impacts, and we are. We're seeing really severe impacts. People that live in California, people that live in Arizona, people that live in the West, people that live in Miami. Everybody's feeling it now. Now, an important thing to understand is that you all very well may feel like climate change is not affecting you. Let me ask you this by a show of hands. Who here thinks climate change has affected them already? All right, well, this is a woke audience, I think. Most people, if you talk to a general audience, most people don't think climate change has affected them. And that's wrong. Climate change has affected you. There's an article in the New York Times just like 2 days ago about how the drought has in Texas, which climate change makes worse, is affecting like cotton prices. So we all buy stuff that has cotton in it. And so the prices are going up. But the thing that's important to understand, this is the one of the main points I want to make is that the impacts of climate change are strongly nonlinear. So what that means is that it's not the case that every tenth of a degree of warming gives you the same damage. Instead, what this means is that you don't have any damage, and then you cross a threshold, and your damage goes up. And the analogy I like to use is imagine you own a house. The house is next to a river. As long as the river doesn't get into the front door of your house, your damage is zero. And so the river level can be going up, and the damage is zero. It goes up some more, damage is zero. It goes up some more, damage is zero. And then it goes above the entrance to the house, and the damage, you have $50,000 of damage immediately. And so most people who think climate change hasn't affected them don't recognize that even if you kind of perceive, well, I haven't really been wiped out by climate change yet, you could be wiped out tomorrow. Because people engage in this linear thinking. They think, well, I haven't been affected yet, therefore, it'll be decades before I'm affected. But instead, it could be tomorrow. How's that going?
It's going about 3 minutes.
Okay. And so we are really on there are lots of places where these thresholds exist in our society. So I have a picture in there I can show you in a second of the expansion joints of a bridge. So here's an example. So this is an example of a nonlinear threshold. So when people build a bridge, they know the bridge is going to expand and contract, and they put these expansion joints, which you've seen on the roadway. They're these things that metal things, and they allow the bridge to expand and contract. When you build that, you are assuming a temperature range. The engineers who built the bridge said, okay, what's the warmest temperature that this bridge is going to experience? They say, okay, well, that's as much as the bridge is going to expand. We'll add a few degrees of that just to be safe. And that's the warmest temperatures. And then that's how big of the expansion they put in there. But if the bridge, if it experiences warmer temperatures, or let me put it differently. So as the temperatures go up, the bridge expands. And then the bridge expands. And then at some point, you exceed the range that the engineers thought, and the expansion joint closes up, and the bridge is damaged at that point. The bridge is damaged. It cannot operate. They have to close the bridge, and they'll have to spray water on it, try to cool it off. I mean, there are all these things to do, but essentially it's an assumption in the system that introduces these nonlinear effects of climate change. And there are lots of these. Railroads. So railroads expand and contract, and the engineers who build the railroads know that the rails will expand or contract some certain amount because they're assuming a temperature range. And if you exceed that temperature range, the rails expand too much and they buckle. And that's a name for that. The railroads call that sun kinks. You actually see the rails are going along and they just buckle. And you can't run trains over rails that do that. And so there are millions of these assumptions, and we are just now exiting the climate that our infrastructure was built for. As we get warmer, none of these things that we've built into our climate system are going to be appropriate. And it is going to be incredibly expensive to fix this. So the important thing is that when we look at the impacts of climate change, even though all of us probably haven't really been wiped out or suffered really severe damage from climate change, we may perceive, you guys understand that maybe you've been affected slightly. Tomorrow, you could be wiped out. I will show you this. This is a real-life example of nonlinearity. So this is Meyerland in Houston. It's near where I grew up. This is a really nice house. You can tell it's designed by an architect. It has like a copper chimney. And it's a 5,000 square foot house in a good school district with a pool. It's a house that's worth a lot. Now, if you look at it, they said mid-century modern with incredibly open spaces, flooded in 2015 and again in 2017, would be a great candidate to lift and remodel. They say incredible curb appeal. I would have led with that. So this is an example. I want to show you an example of what nonlinear impacts really look like. So this is I got this off Zillow. This is the value of the house. So this is year on the x-axis, y-axis is the assessed tax value of the house. And in the 2000s and early 2010s, house was doing great. So it started off at about $400,000. And like I say, it's a really nice neighborhood. It's a big house. The Great Recession was right here. All houses went down. Then it started going up. And, these people were thinking, who cares about climate change? I've got a house worth $700,000. We're going to sell it. We're going to go on a cruise. We're going to pay for the grandkids' tuition to go to college. And then the house flooded. and this is a nonlinear effect. It wasn't, this is important, the damages of climate change did not accrue over decades, a little bit every year. That's linear thinking. Instead, you passed a threshold, the house flooded twice, and now it's worth $200,000, $250,000. These people lost $500,000 of value. And the question I want to ask everyone is this you? Are you sitting there thinking climate change hasn't really affected me, and tomorrow you're going to wake up and you're going to be wiped out? And hopefully it's not you, but it's somebody. There are people out there that is them. Hopefully not y'all. Okay, so there are also nonlinearities in the bigger social system. So even if your house doesn't flood, you can imagine a neighborhood floods, and then as I showed you, the tax value of the house goes down. So the tax base decreases. You get less property taxes. You can't pay for stuff like... very good. So tax base declines. Then you start getting social decay. You can't buy new ambulances. You can't pay for... school districts go down. People want to move. Then that causes the tax base to go down some more. It's a feedback loop. So we talk about feedback loops in climate science a lot. This is a social feedback loop. Then tax base declines more, you get more social decay, more people move. Eventually, nobody wants to live there. The only people left are the people too poor to move. And then the gas stations leave, and the banks leave, and the grocery stores leave, and you end up with this shriveled remnant, an unlivable city that's incredibly poor. And you can actually see this happening now. So, homeowners who can't get insurance, this is going to drive a feedback loop. If you can't get insurance, that's going to drive the house prices down. That's going to decrease the tax base. That's going to cause social decay. People are going to move. You see this happening in Florida with Hurricane Ian. So these are things that are happening, these feedback loops. And again, these are abrupt, nonlinear changes. So even if you feel like, climate change is bad, in 30 or 40 years, I might be affected. You could be affected tomorrow. Right. Okay, so this is kind of a summary of the bad news side of the thing. This is what my my cartoon of what uncontrolled climate change would look like. This is kind of a probability distribution. So the height tells you how likely it is. Now, not everybody is going to be affected equally by climate change. So, before I said, there's really no chance that climate change is going to be good. Virtually no, maybe a few people will be better off, but almost nobody will be better off in any important sense. But how much worse off will people be? Well, if you're rich, you're not going to be that bad off. I mean, after all, Musk, if it gets that bad, he can go to Mars. So Musk, people who are very rich won't be that badly off. Now, what about people like us? Probably not that many people here feel they're rich, although globally we are rich. If you have net worth of $100,000, you are globally in the 1%. If you have $5,000 net worth, you're globally in the top half. But people like us are not super rich. At least I don't feel super rich. And the answer is, It depends. So some of us are going to get absolutely hammered by climate change. Some people won't. We really don't know. And we don't know how bad it's going to be. You can ask economists, they don't know how bad it's going to be. It could be really bad. It might not be really bad. And it'll differ depending on who you are. Now, for the poor, it's going to be bad. Okay, these are people who are barely getting along now. They're not going to be able to get along in a world where the climate has changed. So let me violate SciComm 101, and I'm going to read a paragraph to you, which you're never supposed to do in a talk, but I'll do it anyway. But I think this is so powerful. This is from an article in Rolling Stone by my friend Jeff Goodell about extreme heat in Phoenix. And it shows you how terrible it's going to be for people that are poor. So on hot days, whereas a small apartment feels like a cave, because she has poor credit, her utility has given her a card reader that plugs into the outlet. She has to feed like a jukebox to keep the power on. Res turns on her AC in Phoenix only a few hours a day. Still, her electric bill can run $500 a month during the summer, which is more than she pays for rent. She shows me the meter on the card reader. It has $49 worth of credit on it, enough for a few more days of power. And when that runs out, I am in trouble. These are people that are barely hanging on now. They are not going to be able to deal with a warmer climate. And the result is going to be suffering. These people are stuck. She can't move. She doesn't have enough resources. People often, when I talk about extreme heat, people will say, oh, you're a Luddite. We invented air conditioners. I know we invented air conditioners. Air conditioners are expensive. People can't pay for air conditioners today. And I mean, just imagine living in Phoenix and having to feed the electric meter a few dollars every day to keep your air conditioner on. I mean, that would be terrible. So let me just give you a quote from William Nordhaus, which I think summarizes. So he won the Nobel Prize in economics in 2018 or 2019. It says, technological change, meaning fossil fuels, raised humans out of Stone Age living standards. Climate change threatens, in the most extreme scenarios, to return us economically whence we came. And that's really the challenge. Fossil fuels got us here, but we've got to do something different, or it's going to take back all of the gains it gave us. Now, I'll just very quickly go over some other reasons why we don't like fossil fuels. Air pollution, they kill millions. Millions of people every year die from air pollution from fossil fuels. In addition, fossil fuels are a security risk. So countries like Saudi Arabia and Russia use fossil fuels to weaken the United States. But now the good news. So I gave you the bad news. So now I'll give you the good news. The good news is we have ways to deal with this. We have ways to largely switch off fossil fuels. So we can solve this problem just with existing technology. So this I wrote for the San Antonio paper. You are living through an energy revolution. Most people don't know that. And the reason is because the energy technology is changing so fast that unless you really pay attention, you don't understand how the revolution that's going on. If your knowledge is 5 years old, it might as well be 50 years old. So let me show you one plot of the price of solar energy. So this is 2009. Solar energy was about $350 per megawatt hour. It's 35 cents per kilowatt hour. That's a lot. And over the last 12 or 13 years, the price has now dropped 90%. It is now cost competitive with fossil fuels. And the same thing's true with wind. Wind energy is also now cost competitive. It's dropped 70% in the last 10 years. And people don't understand this. People think wind and solar are expensive energy. They are not expensive energy. They are as cheap as fossil fuels, and that's not even counting the externalities of fossil fuels. The fact that they kill millions of people every year, they weaken our defense, things like that. If you take those into account, renewable energy is much cheaper. Now, you often hear people, I tell people this, and they just do not believe me. It's like, oh, I don't believe you. And then I show them the actual data of what electric ratepayers are paying. And this plot shows retail price. Each dot is a state in the US. And this shows the retail price on the x-axis down here, and the fraction of wind and solar on the y-axis. You can see there's no correlation. It is not the case that states that have more wind and solar energy are more expensive. In fact, Iowa, which gets over half of its energy from renewables, mainly wind, has one of the cheapest energy sources. And so it is decidedly not the case that this is expensive to do. We can do this. Now, I will say, getting to 100% renewables is a little bit of a challenge. We'll talk about that in a second. That kind of leads me to this great meme. This shows Spider-Man in the top panel. Tell me the truth. I'm ready to hear it. And then Spider-Man, Peter Parker says, everyone already knows renewables are intermittent. And then she cries. I can't tell you how many times, like on Twitter, I'll say something about renewable energy, and the person will respond, dude, the sun goes down at night. What are you going to do then? You're going to ask us not to use electricity at night? I mean, we know this. Okay, so we know solar and wind are intermittent, and in fact, there has been an enormous amount of effort to understand how you build a reliable grid based largely on renewable intermittent. So I'll just highlight two studies. This Berkeley 2035 study is really good. This Net Zero America study is also very good. There's an NREL study down here. So lots of people have done, lots of really smart people have spent the last 20 years figuring out how you build a reliable energy system. And this is from the Berkeley study. What it shows is we can get to 90% renewable energy, 90% clean grid. And so this is the year, and this is the price you're paying. So this blue line is with just the dirty fossil fuel grid. And this green line is the 90% clean grid. And you see the prices are virtually the same with these two grids. And so we know how to do this. Oh, and I would say this, before I say it, this does not include the externalities, like the health impacts. So if you include the health impacts of climate change, this is the cost of energy of the 90% clean grid. As we transition to renewable energy, the price is going down because we're killing fewer people with air pollution. And this is the cost of the dirty grid. So it is actually much cheaper to society, to the economy, to switch to renewable energy. And I will skip this in the interest of time. But this just shows the same thing. This is the Net Zero America study. It shows that we can build a grid that is largely, this is a 100% clean energy grid that basically at kind of historical prices that we're spending on energy. All right, so I'll summarize here. We are both on the brink of really bad things happening and on the brink of good things happening. Because of nonlinearities, we can expect climate impacts to rapidly get worse from where we are now. We're just now exiting the range of climate conditions that the world was designed for. And the next degree of warming is going to be much worse than the last degree. We don't know how bad it's going to be. So that's the big uncertainty. For some people, we're sure it won't be that bad. Jeff Bezos will be fine. And poor people are going to be bad. For most people sort of in between, maybe it'll be bad, maybe it won't be bad. We don't know. It's a risk. And you don't leave risks just floating out there, at least in my opinion. And lastly, this is an important point, climate change is not a scientific problem. We understand what's going on in the climate system. It's not a technical problem. We understand how to largely replace fossil fuels. It's a political problem. There are people out there who don't want to solve the problem. And those people, unfortunately, have an enormous amount of political power. And that's really the battle. And so hopefully, you guys will be involved in this battle. Be lawyers, suing people, and, getting legislation written and things like that to solve the problem. And I will end with a quote. I'm going to paraphrase this again from William Nordhaus, which I think is quite good, which is that he says something to the effect of, I often talk about climate change as the climate casino because, it's this risk that we really can't quantify. It's irresponsible to roll the dice. We don't want to run the experiment and find out how bad it's going to be. And maybe we'll luck out and it won't be that bad for most people. Instead, we should turn around and walk out the casino. And that's exactly right. We know how to solve this. We don't want to roll the dice. Thank you. So I have some time for questions. So
if anyone has questions, we have someone in top.
Question here. With regard to what we can do, there's always the question of who is we. And if you look at it on a global basis, the United States, Canada can do lots of things. But if India and China don't cooperate, aren't we just doing a drop in the bucket? Because what they're doing with what the Texans they have, we can spend years doing it, and if they're not assisting, then isn't it net zero at that point?
Right. So yeah. So I guess I have a. You take a look at it? I have some slides on that. China is building out renewable energy as fast as they possibly can. So just to give you an idea, in 2015, China had 360 gigawatts of wind and solar. In 2020, they had 536 gigawatts. And in 2025, they're going to have 1,100 gigawatts. And just to give you an idea, U.S. power in 2021 was 445 gigawatts. They're going to build an entire U.S. of wind and solar in the next 5 years, actually 3 years. This probably came out 2 years ago, so in the next 5 years. So they are cranking renewable energy. They understand this. They're not stupid. And now, they also can't shut down. There is a transition risk to going to renewable energy. You can't shut down your fossil fuel power until you've got renewable energy to take over. That would be the worst thing to do, would be to stop burning coal if you don't have power, because then you have blackouts, you lose political support. So there's this period of transition that's really dangerous, that you have to transition at a rate as fast as you can build. So they're still building coal-fired power plants, and they're going to continue to burn coal. They're going to continue to increase their emissions until about 2030. And in 2030, they will start declining. That's what they say they're going to do, and all evidence suggests they're on track to do that. In fact, they're on track to peak earlier than 2030. And they're going to hit net zero they say they're going to hit net zero by 2060. And I think that of all the places that can do it, they don't have the political problems that we have in the U.S. of maintaining, although perhaps the COVID thing punctures that a little bit. But the point is, I think this idea that these developing countries aren't doing it. I mean, maybe Russia's not doing it, but China and certainly other countries are moving ahead. And the price of renewable energy has dropped so fast that at some point, this is going to be the cheap energy, the cheap way to develop. And I think that's the role that the U.S. can play, is in helping develop the technology, the new battery chemistries, the new battery, these other things, how to electrolyze water efficiently to get hydrogen, that will allow us to help these other countries do it. I mean, the U.S. still has an intense ability to lead the world, and I think we need to continue to take that opportunity. Yeah.
Talk quite a bit about renewables as one technical solution to this. What's the potential, both from a technical and from your perspective from a political standpoint, of re-engaging with nuclear power as one way to mitigate the problem in the short term?
Yeah, so in the short term, I don't know that there's a lot of. Nuclear is not cost competitive. I mean, it's not. You talk to nuclear people who really like nuclear, and they really feel persecuted, like people hate nuclear, and I don't think that's it at all. I think it's just too expensive. You look at these nuclear plants we're building in Georgia, they're billions of dollars over budget. The ratepayers are just going to get absolutely hammered by that. I personally don't oppose nuclear. There are a lot of people who do. I think nuclear is fine if you can get it cost competitive, but it's not, and maybe it could play some role in a power system that's largely dominated by wind. I mean, wind and solar are so cheap now. Solar energy is the cheapest energy in the history of mankind. Nuclear does have the benefit that it runs all the time, and that's worth something. But I mean, it's 10 times more expensive than wind and solar. So I think, we have to be open to it, and I'm glad to hear that there are people that are doing research on these small modular nuclear reactors, for example, and things like that. But until they build one and they show that it's cost competitive, I think you don't want to do nothing with the hope that nuclear is going to bail you out at some point in the future. You've got to go to war with the army you have.